This question is about factors. The equations of the lines L and M are given. C is a constant. The angle between the two lines is 60 degrees. Find C. So in the MF19, we have this formula for factors, the only formula about factors. So we're going to just use the formula A dot B. So in this case, because we're talking about lines, we have to use the line direction. So we do not use the point factor, but we use the line direction factor. Okay, so this is the point on the line, this is the line direction. Point on the line, line direction. So we use the line directions 1, 1, 2, 2 minus 4, C. The dot product is, this is the formula to find dot product. So you multiply corresponding components, the x with the x, minus 2, 1 times 4 is 4, 2 times c is 2c, equals the magnitude of A, magnitude of B. So the magnitude of this factor, which is the square root of 1 squared, 1 squared, 2 squared, add everything. The magnitude of B, same concept. So you do square root of the sum of the square of each component. Cos the angle 60 degrees. So here you have 2, and use your calculator, you get root 6. Use your calculator, you get this is 4 plus 16, 20 plus c squared. Cos 60 is 1/2. And from here, just do the algebra. You multiply by 2, so 4 plus 4c, and cancel out the 1/2. And then you square both sides. 4 squared plus 2 times 4 times 4c plus 4c all squared, and you square 6. You square, you cancel out the square root. If you square, you cancel out the square root, and just rearrange a little here and multiply and move everything to the left. So 16 minus 6 is 10, and 16 minus 120 is minus 104, and then use a calculator. You will get 2n minus 26/5. The negative value is rejected because in the question it says the c is a positive constant. Alright, next. Show that the length of the perpendicular from this point to L is root 11. So first of all, the line L is this line, 3 minus 2, 1, 1, 1, 2. So we use this factor equation of the line. We are looking for the distance from P to this point Q, which is called the foot of the perpendicular. So this is the length we are looking for. This is also the shortest distance between the point and the line actually. So to find this distance, we need to find the length of the factor PQ, the magnitude of the factor PQ. To find the magnitude, we need the factor. To find the factor PQ, we need to find the coordinates of Q. So first, let's find the coordinates of Q using the fact that PQ is perpendicular to the line. So PQ is perpendicular to the line. We can use the factor PQ. The factor PQ is the coordinates of Q minus the coordinates of P. So x, y, z minus 6 minus 3, 6. Because we don't know the coordinates of Q, we just call it x, y, z for now. So x minus 6, y minus minus 3, and z minus 6. The line here, we use the line direction factor. So the 1, 1, 2. To find the dot product, we do 1 times x minus 6, 1 times y plus 3, and 2 times z minus 6, which is 2z minus 12. So we just move minus 6, minus 12, minus 18, plus 5, minus 15, move to the right, plus 15. And since the x, y, z, the point Q, is on this line, we can always replace x with 3 plus 1 times lambda, So we replace x with 3 plus lambda, and we can replace y with minus 2 plus lambda, and the z with 1 plus 2 lambda. Okay, we have everything in lambda. Now we can find lambda. So this is 2, this is 4 lambda, 1 plus 1 plus 4, that is 6, and 2 minus 2 cancel out. Move the 3 to the right, so minus 3, we get 12, and divide by 6, we get the lambda. So if we know the lambda, we can find the coordinates of q. The coordinates of q would be, so you plug into the original line equation, the lambda is 2, so 2 plus 2 times 1, and so on. So 3 plus 2 minus 2 plus 2, just replace the lambda with 2 here, and we get the coordinates of q. To find the coordinates of, the factor pq, again we do q minus p, and we get the factor pq. And to find the length or the magnitude, we use the square root of each component squared, sum square root of. Alright, I'll see you again next time.